This is an overview of the parts of the Los Angeles class radio control model, the 688I, which the I stands for improved. So we're going to take a look at all the parts. And we're going to start with the bow here. Now the bow holds a ballast tank, which is a Sullivan RST-6 tank for model aircraft, glow fuel. It works really well as a water ballast tank. This is the bow. The bow is cut out for fitting the Sullivan tank, like so. And then here's the propulsion battery. It's a 6-volt, 4.5 amp hour battery. Wiring is color-coded with the Dean's connector. And we're going to take a look at the hatches. The hatches on this submarine are on the bottom of the sub. They are filled with BBs and epoxy. And those are 632 by 3/4 stainless steel socket head screws. Each one has a silicone rubber tubing washer on it. And that helps with the sealing of the ship. So the hatch seals are twofold. There's the hatch seals around the screws, and then there's another set of seals around the bay. This is the pump assembly, disassembled. We've got the motor unit here. That's a GWS motor, a 380 type. This is the combination pump and motor mount. It's an epoxy casting. And this little gadget here is the geared pump taken from a hand crank fuel pump. It has a lot of power, so combined with the motor, does an excellent job of moving ballast water on and off the boat. Next over here, this is the propulsion system. The motor is a 400 geared motor, a GWS motor. The motor pod is 2 parts. These are epoxy castings with a RTV silicone rubber gasket seal. There's the top part, goes on here. So I'm going to slip the motor into the pod here. I'm doing this one-handed, so it's a little ungainly. There we go. So when it's all put together, of course, I'll straighten out the gasket. Put these little tabs here so that I can position the gasket when the two halves are together, make sure that it's all set up and aligned properly. The ringed propeller, of course, which is the hallmark, probably most recognized thing about the 688I. Here's the set of tools necessary. Not that much, but Allen heads for 632, 440, and then the number 2 socket head sheet metal screws, which hold the bow and stern in, a pair of needle nose pliers, a straight screwdriver, standard screwdriver, and a Phillips screwdriver, and a small open-end wrench. So 5/16 and 1/4. So the 1/4 is used to put on the little lock nut here that goes on the end of the propeller dunce cap, right there. So next we'll move to the stern. Here's the stern, it's removable. So you got the rudder, upper and lower dive planes. And then take a look inside. Those are the handmade control yokes. The openings on either side, so we get light, there we go, give access to the control horns. The control horn is aluminum. It's part of the control yoke. And then on the other side here, these also act as excellent drainage for the wet section that these reside in. Okay, now let's move on to the stern of the ship. And here we've got Now, nobody's been able to tell me what these are, but the 688i has what I'll call anti-submarine warfare fairings, no doubt for weapons deployment or further sonar deployment. Somebody who actually serves on one of these ships could possibly tell us, but I doubt that. It's most likely classified. The waterproof push rods are constructed out of Sullivan aircraft push rods. They have large silicon rubber fuel tubing, which has RTV silicon rubber embedded inside to the exact size of the push rod wire. These are standard aircraft clevises. Let me move the motor pod out of the way here. So the clevises snap onto the aluminum control yokes. The wiring here is for the motor pod and motor. The connectors actually fit inside. Oh, got grease all over my fingers there. All the exits to the pod are greased up to keep them waterproofed. And let's see. Inside the stern, that gray piece there is the mount for the pod. So the pod mounts in there. You can see the push rod exits. So once the motor is encased in the motor pod slips onto that mount right there, and the mounting screws go through those two holes and these two holes. So 4 holes altogether. These holes are aligned with the socket head screws that mount the pod to the hull. Okay, so now let's move to the number 5 compartment. Number 5 compartment holds the rudder and dive plane servos, as well as the electronic speed controllers. So the electronic speed controllers are M-Tronics Marine 15s. Oh, there we go. And if I pull back here for a bit, see if I can hold this steady while I take these guys out. It's a bundle of wires here. There's one speed controller for the propulsion motor, one speed controller for the pump motor. And then there's the receiver. Oh. This is a Futaba 75 megahertz receiver. Let's turn it over so we can read what it says there. Okay. So the 5th bay is the electronics bay. Now this is a medium fuel tubing, medium silicon rubber fuel tubing seal. Goes all the way around and is joined here by a metal peg with RTV silicon rubber. So it's joined on the inside of the tubing and the outside of the tubing. Makes for a very tough unified seal. Okay, so moving forward here. This is the isolated pump chamber. The only apertures in this chamber are the hatch itself. This is the ballast pump fill line. This line goes directly to the RST-6 Sullivan tank in the bow. And then this line is the ballast intake and outflow. That's connected directly to this pipe here, which is the only exit through the hull. It's the inflow for the ballast and outflow for the ballast. So the reason for the isolated compartment here is because the drive shaft, this little metal shaft right here, is not waterproof or airtight. So when pumping water through the pump, often that water is under pressure. And in my older version of the submarine, the pump was located in the main body of the submarine, and when the pump was at rest, air would seep right through here, through the shaft and out through the ballast. intake. So if you can imagine, losing air through there was a little bit disconcerting, although through many experiments and actually trying to sink the sub, I never successfully did that because we never did lose enough air to put the sub in danger. I just don't like seeing the bubbles. So we put the pump in its own isolated chamber, so the only air that can be lost is from this chamber, which, if you look at all the chambers together, that chamber is one of the smaller ones, and air loss from that chamber is inconsequential. Okay, so let's go to the central chamber here. This is the main ballast chamber. It's empty of everything except for silicone tubings and the tubes that go through that are sealed on either end. This is the feed pipe coming directly from the forward ballast tank, the Sullivan RST6 tank, and this fills and empties the ballast water. Now, this sub is set up with two different versions for ballast running. For this setup, this is the snorkel setup. You can see this is the vent tube for the snorkel. It's less than halfway up, and that's all that it takes. When this chamber is half full, this submarine will submerge. So the ballast tube is routed through the bulkhead here, goes through the silicone rubber tubes here, and you can see in the next chamber, this is just an auxiliary extra chamber. It acts as an overflow for the main ballast chamber under some circumstances. And this rubber pipe right here is connected to a brass tube which goes straight up through the sail. And let's take a look at the sail. Right here is the ballast vent tube. So going back down again, here's the silicone rubber fuel tubing that leads from the ballast exit tube on the sail through the bulkhead and to this vent line right here. Okay, so this is, like I said, an auxiliary ballast chamber as an overflow chamber. It's not needed as a ballast overflow chamber under normal operations, but the airspace inside is very important to the buoyancy of the boat. Okay, and then going the rest of the way forward, we have the first chamber. This is the battery chamber. You can see here we have the 14 gauge red and black wires with the Dean's connector, and this connects up to the battery here. And the battery will sit in the chamber like this. Now I'll show you how that works in a little bit here, but let's trace the wiring. You can see the red and black wiring here, and as we move through the chambers, that red and black wire goes all the way through and exits in the fifth chamber. So it gets divided between the two speed controllers, and the speed controllers power the receiver and the servos. So that's one set of conduits, and that's for the power system. There's another set of conduits, but these are brass tubes. Oh, well, hold on a second. This yellow tube going through is the receiver antenna tube. And it exits into the first chamber, and this is the end of the receiver wire. This yellow antenna tube came with a little black cap, which is on the end of the yellow tube over here, so that makes the exit of the tube hard to see. But you can see, if I pull this, it points directly at the yellow tube in the second, third, fourth chamber, and it exits in the fifth chamber, and the receiver wire is routed through there. So that stretches the receiver wire all the way across the top of the sub where it will receive the signal best. Okay, so that's another conduit. And then finally here we have the brass tubing conduits. I'm going to bring some more light over here. There we go. Now that brass tubing is for ballast water or air. So from the sealed ballast chamber, you can see that the silicone rubber tubing there is connected to, let's see, there we go. It's connected to a brass tube. That brass tube runs all the way forward through the number 1 bulkhead and is connected to the forward ballast chamber. So if we look here inside, see if we can get some light in there. There we go. You can see that there's 2 sets of silicone tubing that are connected to 2 brass tubes. So we have a fill and an exit line. There we go. It connects itself to the bow ballast chamber. The rest of the bow area in front of that bulkhead is all a wet section. So it's vented through these 6 holes in the bottom, and the air vents are these smaller holes on the top. Alright, so that's how the ballast runs through. There's also, right there, that's a capped line. When I'm running the snorkel system, I don't need that tube to be open, so I close it off with a piece of silicone rubber tubing and a brass rod. That tube runs all the way through to the 5th chamber, and that's to share air between the chambers. Each of these chambers, except for the sealed ballast chamber, each of these chambers has tubes running through the bulkhead so that it can share air between the chambers. And that's necessary for when we're running the pressure hull system. When we're running the snorkel system, not all those tubes are necessary. They can be capped off or left open. It actually doesn't make any difference. So that's a general overview of the parts of the boat. It's taken apart now as a systems check after doing the shakedown in the water tank. It's been running for over an hour, submerging, surfacing, submerging again, running the power systems for the propulsion. Want to make sure there was no leaks anywhere that they're not supposed to be, and make sure all the hardware is breaking in and operating the way that it should. So that will conclude our overview of the parts of the Los Angeles class 688I model submarine in approximately 1/100 scale.